Hello everyone, today I'm going to talk about the frame. So here we have a frame and we want to solve it by stiffness method. This is a frame, we have this is the member number 1 and this is member number 2. On member number 1 we have distribution load by 24 kilonewton. And for member number 2 we have only one force, 75 kilonewton. So first of all we have give global system for this structure and then divided the frame for two parts and change it to fixed end moment. So here the global system, this is member number 1 and this is 2, and for the direction start with moment, and because we have this one is a hinge, so I will start I already started this moment number 1 and this is the moment number 2. Then give it the force, known or unknown. This is the 3 and this is the 4, and then continue with the fix it or go back to the hinge, is up to you. But to make it a simple structure, a simple solution, start with known forces, because it's easy when you calculate to make some problems especially when you collect the matrix. I can do this is the moment 1 and this is 2, 3, moment number 4, 5 and 6 and so on, but I will, when I collect all matrix of K to find the F, so it will be make it a problem, especially here in the F. So the first, just in the beginning, make sure which part I want to give a number for each one. So for the frame we have two forces, horizontal and vertical, and moment. So each point or each node has 3 forces. Then also take which one is far node and which one is the near node. So for number 1 I will take, this is the near and this is the far, and for number 2 this is the near and this is the far node. Okay, then change to fixed end system or fixed end moment. Depend on the tables you can find in Google. How you can solve the moment and how you can find the moment and find the reaction for each part. For member 1, actually I make it both sides, fix it, up to you, and calculate the moment and the force. Same here, calculate only one force actually. Okay, and this one also for beam number 2, and then if you want to collect and put it in one structure, is up to you. So here for this one, the known force, here we have 4 nodes. The nodes is, this is the number 1 node, I mean the rotation or the moment, this one, number 1, and number two is the moment number 2, Number 3 is the force number 3, and this is number 4. So these forces actually noun forces, and the displacement, the others is 0 because we don't have in this example any settlement. So all values is noun displacement, and all values substitute is 0. Okay. Yeah, and let me to this is 5, 6, 7, 8 and 8 and 9. Okay. Then take each member alone and find the lambda x and lambda y. Lambda x, same rule that I explained in previous videos about when we solve the set truss by stiffness method. So lambda x equal x far minus x near divided by length of the beam that you want to find lambda x and lambda y. And for lambda y is same, but use the y direction, yf minus yn over L. You will get the value of lambda x and lambda y. Because in this, actually in a frame structure, we have a big and difficult, not difficult actually, just big size of matrix as you see here. This is the matrix, K matrix of a frame. EI is constant, and the length is only the beam that you want to work it. You take only the length, and here we have lambda y square, and here lambda x square, lambda x and lambda y. All cells of this matrix we have lambda x and lambda y, or some of them we don't have. So just substitute your values and actually find the others elements like AEL and 4EIL and 12. This is constant, 12 EI over L for power 3, and 6 EI for divided by L square, and 2 EI divided by L, and you get the values. And EIA all is given, but just want to change the units. So, and substitute your values. Okay. And find this is the K1, and go to member number 2, same, find the lambda x and lambda y. Okay. And also the some elements or factors that inside your matrix, like AEL and 12 EI, so on. And this is the values of matrix number 2. So let me to give you the numbers. Actually, maybe it's actually it's unclear. This is the 6, 5, 7. You can go to previous videos about the truss and why I give these numbers. Here we have because this one we need it to collect the all cells or elements of K, total K matrix. Okay, then this is the our k. K total. Then find the unknown displacement. We have theta 1, theta 1, theta 2, d3 or small delta up to you, d3 and d4. These values are unknown values. And here we have the known values. Known values, you can get these values of f. Okay, these get it from this one, the fixed end moment, from this one. Okay, and find the unknown values here. You find after that, get the values. These are the values of theta 1, theta 2, d3 and d4. After that, go back to find the f unknown. Unknown force, that means this, the other part is f5, f6. We have moment here, moment 7, m7, then force for global system 8 and for 9. Find it during same matrix, so you will get this matrix, this one, the K21. Okay, and this is the values that you get it. After that, go to find the actual forces. Actual forces is just the value of that you get it, this one, this value, plus the value of fixed end moment that you get it when you change the members to fixed end moment. This is the value of fixed end moment, this matrix, plus this one. Okay, you will get these values. These values, during it you can draw the shear and moment, bending moment. So after that, before that actually, find the transformation matrix. This one, transformation matrix, is constant matrix. Okay, you can take it for all members, depends on your structure, frame structure, how many members has. So depends also about lambda x, lambda y, and this is one here, and the other elements 0. For actually this, for member number 2, I solve it. Internal forces for member number 2, because transformation matrix, this matrix, I want to find the internal forces through this matrix. So the internal forces, we have K, this is the K of member number 2, transformation matrix for 2, just substitute the values of lambda x and lambda y of member number 2. And if you want for member number 1, same matrix, but just substitute their values, and the displacement. So this one, the K2, this one, transformation matrix for member 2, and this one is D. Okay, the matrix. After you calculate, you will get the values, and be careful with the units. Then collect or summation these values with fixed end moment values to get the actual forces. This matrix, the actual matrix. You can draw the shear force and bending moment diagram. It depends on the actual forces matrix. So here in last slide, this is our structure, and this is draw the shear force diagram and bending moment diagram. During the forces or the internal forces plus the fixed end moment forces. Okay, depend on these values or these two elements, you can get the drawing. So thank you so much.